what we discussed yesterday? We discussed yesterday about the functional way of comparator interface, right? So comparator.comparing and then comparing. Comparator.comparing is a static method. Then comparing is the default method. You can have multiple chaining. And also we discussed about what? After comparator, what we discussed? No? Everybody forget the concept. We discussed about reduce operations, some more terminal operations, how to collect a result as a set, as a map, how to use joining, and also how to use reduce. So in that reduce, if you're working on a parallel stream, it's absolutely, single stream. You can apply plus, minus, star, division, whatever it is. But when you work on parallelly with this reduce operation, either star or plus is efficient, but don't work with subtraction. And also we discuss some of the method called max, min, find any, and find first, but those are written an optional type. And we discuss how to create your own optionals, right? Then what we discussed? How to do the null check with the different optional class types. So that also we discussed. Okay, let's go with our today's summary statistics we discussed. Okay, here are the theory knowledge. Primitive stream type. Okay, so I have already created some test code to show you this. Okay, please keep quiet. Okay, so let's go over today's demo with the primitive streams, but this code is not available on your demo package. Just I created yesterday. I can post it by today's lecture once I'm done. Okay. So if I want to work with the primitive streams, better to work on use primitive instead of, so I don't, the recommended is don't use stream integer. The recommended, if you want to preferably working on primitive types, we have so many primitive streams are available for all primitive types, better to go with. If you have primitive stream, whatever you work with the stream, like filter, map, all intermediate and terminal operations, you can even work with primitive streams. So that's what, even you can make your own primitive stream collection, the generate method, iterate method, everything, whatever you work with stream, everything you can work with primitive streams. So for example, this is a primitive stream. I want to make my own streams, not directly from collection. We can call into stream.off. So it will return a primitive stream. Okay. Then I want to find the maximum value. So all these primitive streams, if you look at which method you use, max min will return an optional type. But in this case, it's a primitive. So what is the return type here is optional integer. But if it is a stream means, what will happen? Stream of integer. But now we work it on primitive stream collection. So it will return an optional integer. When you want to get a data, if it is a stream, simply you call get. But for the primitives, you have a separate getter method as integer, as float, as double, whatever you want. Let me know if you have any question on these three lines. The same way you can work for long, float, double, whatever you want. Okay. So for an example, we use iterate on the stream to get infinite streams. All methods you can work with even a primitive stream dot iterate. So it will iterate infinite streams. So I'm going to limit it. Then I'm going to print it. Okay. Any question on this line? Okay. That's what the slide number. What is the slide number 81? Did I mention slide 81? Yes. So up to this part is your primitive stream examples. Okay, some more informations for your knowledge. Even you have a range method. If I want to use iterate, it will generate infinite stream, right? I want to generate a natural numbers with this range 0 to 100. Then if you use range, 100 is excluded. If you want to include a range, you can go with range closed. Okay. And I have a stream of integer stream. If I want to convert it into an objective stream, just simply call boxed. So this will be converted into an object type to the primitive stream to object stream. And so we have several methods to convert your object to primitive. You can apply a map function. If I have stream of integer, I want to convert it into a primitive stream. What you can do? Map to integer, map to long, map to double. So this is what. I have a list of words. I want to convert it into a primitive stream. So instead of doing direct map, if you use map to integer, so all the string inputs are taken and converted its length and collecting as a int string. So this is the way primitive to object and object to primitive, whatever you want. The same way for optional class also, you have all primitive types available like optional integer, optional double, optional long, everything is available. Okay. So this sum average max min will return a optional type. So this method only you can use count, but the average max min will return an optional type. So that's what. But if you want to customize it, you have to implement a comparator to find the max or min. For example, I have an employee collection. I want to find the employee who is getting high salary. So if I want to call max, inside the max, you need to pass a comparator because inside the employee class, you have several types, right? Which type wise it has to find max. So at the time you need to customize comparator as an argument inside max, even for sorting. Okay. So the important knowledge, streams can be reused. Let's check this example. Okay. Okay, terminal operation. Look at this scenario. I have a string which is defined here with several string inputs. I want to perform a stream. Then I want to filter a input, start with A. So the return type is stream of string. Any question on this two lines of highlighted code, selected code? I have input stream. I want to filter a name starts with A. So what is this filter? It is an intermediate operations, right? So I applied, you can apply many intermediate operations, right? But only one terminal operation. Okay. I have the stream object named as STM. I'm going to print stm.forEach. So this for each is a terminal operations, right? So your source is stream. For this stream, I applied a terminal operations. When you run the code, it will print the name which starts with A. So I will get two inputs in that stream collection, which is Android and Angular. Okay. I already applied one terminal operation. I'm trying to apply another terminal operations here. Okay. So you know that count is a terminal operations, right? So the same object, this is my stream object. Already I applied for each. Again, I'm trying to apply another terminal operations. When you run the code, it will pass runtime error. Okay. See, illegal state exceptions, line number 36, because of I already applied for each terminal. Then if I apply again terminal operation, it will throw illegal state exception. So streams cannot be reused. Once you apply the terminal, you cannot reuse the stream. Any question on this part? Look at this code and let me know if you need more clarity.
The one that stateful line STM.
Which one?
The line 35.
Line number 35.
Yeah.
It is in terminal operations. We talk about state or stateless only for intermediate, not for each. Okay, state or stateless is belongs to intermediate.
Yeah, I understand this one, but I want to try with the static, the stateful operation. So it will probably exception.
I don't get your question. What do you want to make change?
I want to make change from the STM dot is to STM dot sort.
STM dot short. That is intermediate. You can do. Okay, you can do STM. Okay, over here I can remove the semicolon. Okay, you can even put dot.
Still keep the semicolon there, and then we can add the end of sort. So two lines separate.
Huh?
STM dot
You want to put semicolon there?
Yeah.
Okay, it's a intermediate operation. You can do stm dot shorted. You can do stm dot shorted, which is an terminal operations. Okay, I can comment line this one. Okay, still it print values in a shorted order. Okay, so what it says. We apply. Okay, maybe shorted is a terminal. Terminal operation. Okay, let me pull out. I have some intermediate and terminal. Shorted is an stateful operation. Let's see. Returns a stream. It is an intermediate. Why I'm can't print. Okay, let's put shorted dot for each. So this time will work. Okay, let's see the return type of shorted. It's a stream of string. So I'm not sure it is a strange. Okay, let me put this one. Okay. And I want to, instead of this one, let's collect. Collect is a terminal operation. Let's see what it says. List string. List is equal to stm dot collect collectors dot to list. Collectors dot to list. Oh, what happened? I have to import. Okay. Okay, so let's put, let's see how it works. Still collect the after shorting. Stream has already been operated upon or closed. So maybe it's a stateful operations. If you do for each, it will work. But sorted is an intermediate operation only. So because of stateful, after that, I cannot do this like this, another terminal. Okay. So thank you for letting me know. This is a new thing. Okay. So because of stateful transformation. So stateful transformation. Transformation.
So that if it's to return a new string, so we have to get the string there.
Okay, maybe we do another filter. You want? STM?
So that returns a new string.
Yes.
That's the problem, right? If you assign an answer variable, string variable.
This is what we did, right? Streamed, when I put remove semicolon, right? You collected as a stream. Huh? What do you want to do?
Sorted should be assigned in another string. It's a new generated string.
Okay, you want to hold it in another string?
Yeah.
Okay. Stream. String. String. Stream1 is equal to stream1 dot starter. Then if I do stream1, you won't get any error. That's what you mean? Okay, let's run this one. Okay. Yeah. So where is that? Oh, I have to print it, right? Okay. So after collecting the list, can we do another for each? Okay, for each system dot out dot printed. Okay, you need some another stream. Okay, because of stateful transformation, still it printed, right? Okay, we applied for each. Let's try with stream one. Okay, so instead of stream, you can do with stream one. You will get illegal. Okay, so stream one. What is that? Stream one is shorter, right? Okay, LIT, right? I have to call with LIT, right? No, this one correct. I applied to list, right? And over here, okay, let's do this one. This will work, right? Yes, it's already tested code, it work. Okay. So for this scenario, let's forget about start. This is a scenario of stateful information. Again, collect as a stream, then apply another terminal operation. For this case, your stream has filter. So if I do stm1 dot stm dot for each, so after that, one terminal operation is applied now. When you try to do again, this line will cause illegal state exception. Okay. So this will cause an error of line number 40 due to the same, shorted, right? Because of shorter. Okay. So without shorter, you can assume the scenario. Okay. Any other questions here? Short with? Yeah, you can do and several filters and mapping, it works. Okay. So you can test that by yourself and let me know. Okay. So many have different ideas. You can test everything. If you have any confusions, let me know. Okay. So according to this scenario, once I apply the terminal operation, if you try to invoke another terminal operations, it will give you an error. So that's what we are talking about here. Streams cannot be reused. Okay. Because of unusable. Once you apply a terminal, there will be no stream anymore. So you cannot apply any other terminal operations. Okay. So how can we conclude this session? If I want to reuse, we are discussing some solutions. So whenever you need a stream, every time we are doing words.stream, words.stream, word.stream, right? So instead of that, that stream generation converted into a one method. Whenever you need a stream, just call the method. So for example, over here, I have the words collection here. So one time I can filter by A, then another time I want to map it into a uppercase letter. Different things I want to do. So what we can do it is, you can create a method, get a stream or whatever name you want, pass a list of string and return string. So whenever you need a stream, this is also same job we are doing, but every time we are not going to call dot stream. Instead of that, just we are calling a method. That is the one approach. Something you need multiple times, generate that part as a method, then you can call it. Okay, let me call this, call the stream method, to invoke for different functionality, for different purpose. So for example, what we are going to do it is, whenever I need a stream, I can call this method. So my method name is get stream. So what is my input name here is names. Okay. So get stream class names. So which will return a stream. So then I can dot filter, whatever intermediate operation you want to do, you can do. Take a input dot starts with of A. Then I want to make capital letters. Okay, let's try this one dot. I want shorter. Let's do dot map. Take the input and map it into uppercase. So what I can do, method reference string colon to uppercase U capital or small. Anybody know that? Capital U, uppercase. C capital. Okay. C capital. Then dot for each. Let's see how it works. For each system dot out dot println. Let's run this code. I put sys out stream reuse by method call. Okay. So let's run this code. Okay, I have to remove something, these lines to avoid errors. Okay. Okay. So I can get Android and Angular. So after sorting, you can even apply another map or filter. Okay. So now I want to do some other functionalities. Whatever you want. Okay. I want to convert this into a integer arrays. Okay. I want to collect as a stream of integer. Okay. Then yes, int. Yes, list is equal to, I need a stream. So simply call stream. So whenever you need a stream, simply capture in a method and dot map to take the input with its length. So string colon length. Okay, it will return a stream of integers. Then I'm going to apply collect operations. Okay, so let me collect as a list integer. List integer. I want to do dot collect collectors dot to list. Okay. So then I'm going to print the numbers in a shorter order. So whatever in not a shorter order. So S list. I'm going to print the list. Let's run this code. Okay, this is one scenario. The solution one is whenever you want to reuse, just capture that code in a method and you can reuse it. So let's see this code in the stream reuse package. So you can refer this package while you're doing a homework. So you need to refer this package. Let me show you from there. Stream reuse. Stream reuse. So over here, I have a data collection, which is false class. Whenever we need a data, just we can call folks.friends if I need a friends data, because we capture these data as a static. So you can just call this method dot if I need a friends collection, if I need editor collection, comrades. So this is your data class. Let's go to the good package. What we are going to do it is we want to reuse. So sometime I can filter with by n. Then sometime I want to count the number of words start with B. So I want to perform several things. So what we are going to do it here is create a method which return a stream. Okay. So where is that stream class? Okay. So here is the method. Whenever I need a stream, I can pass the list. Even the start with letter also you can pass it. So this is your filter logic. Up to this part is common. So one time I can pass B, one time I can pass N. So we can capture this one. Whenever you need a stream, just start with, I can pass N. I can pass with whatever input you want. You can pass different list and different character. This is the solution one. So the solution two is capture the common part. Instead of going for a method call, we can go with the functional interface. So just method dot apply. Whatever code you want commonly, capture that part as a type of functional interface. Then whenever you want to apply, just call with different data. That is the solution to capture all the free variables and all the parameters, whatever you want. Those function you can convert it into a suitable functional interface. Look at the scenario. Okay. What this method will do, take two inputs. And what is the return type of this method? Stream. So how can I write this one? Okay, let's go over here. I want to capture this one as a functional interface. So how can I capture this one in a functional interface? Take two input and return a input of stream of strings. So what is your first input? List string. List string. What is your next input? String input, whatever character you pass. What is my return type? Stream of string. So this is what you can capture. So maybe query 1. Excuse me. I'm keep getting your conversation. If you want to talk, please stay there 5 minutes, communicate everything, then come back. Okay. Sorry about that for saying. Okay. Query 1. So what we can do it is convert everything into a suitable functional interface. So what we can do, write your implementation. Take 2 inputs, right? My list, comma, your character start with. So start with input, then write your body. Okay. So inside this body, you can do the implementation. What I need to do to make my input dot, list dot, why it doesn't come? List dot stream dot filter, take the input, input dot starts with the letter we pass, right? That's it, right? This is the common part. Do I need semicolon? Return. Yes, so I have to import this by function. And finally, I have, okay, this I can put return keyword, right? Then everything is fine, right? That's it. So you have to think about if you are doing some functionalities, I need these functionalities repeatedly for reusability. Every time repeatedly function.stream calls that object.stream, then you need to write this line several times. So capture everything commonly, either as a method or the better way is capture as a functional interface. So that is your solution too. So useful stream pipelines. So if you have like this, you can have one utility class which has all static by function, whatever queries you have written, just simply that query when you are working on a database scenario. So that's what in the good package we did like this, right? So we created some functional interface that is inside the reuse. Okay. So what we are doing is converted into a suitable functional interface. Then whenever you want, simply call that. So that is your solution 2. So when we do like this, we can make our Lambda library. What is the concept of Lambda library is if you are working on a database, something, if you want to extract some data from your table and store it into your any of the collection, whatever queries you want, how you are writing an SQL query. Look at the scenario. Select name from the table customer where city like starts with MA and I want to sort by name. Okay. So now if you have this kind of criteria I want to do. So look at that requirements. Think about what are your input arguments and what is your return type. Then identify the suitable functional interface. Look for this scenario. What are the inputs you need? Okay, let me copy and paste this query. Okay, here is too much big. Here is your query. Select the name from customer table where city start with MA, order by name. So how can I write this into a suitable interface? First capture the input. What is your inputs here? Table, right? So you need a customer, right? So customer table. Over here it is a customer list, right? Customer list start with, right? Some criteria you need to know the name city starts with. City starts with. Then that's it, right? 2 inputs. What is your output? I want to return a list of string, right? It should be in a shorter order, right? Okay, what will be the suitable interface for this? 2 inputs, return an answer. So by function. If this requirement need more input, you can create your own interface. Okay, so what is your input? List customer is your first argument. List customer is your first argument. I have to put a bracket. This is correct, right? Comma. What is your next input? String, city name, and sorry, no arguments, right? String. Then third argument is list of what we are returning. Order by name. We are not sure. We are returning a customer or here, right? So even I can return a customer, which is started by name wise, right? Okay. So then close this one. Put your object is equal to short by name. Okay, let's see what we are trying to return. Okay, list of string. Okay, list of string. List of names. Okay. So now, can you tell me the implementation of this body? You need to pass arguments, right? So before the you have to pass the arguments, customer list and city name. Take a input of this and what I need to return inside this method. So you can have a return keyword or you can have a temporary list and store it whatever you want. Retrieve into your list and store. Okay, let's store list string result is equal to, how can I write it? C list dot stream dot. So this is what you need to practice, how to write it in a paper. Okay, without editor for the exam. Dot filter. So you have to take the any input and x dot starts with C name. That is important. Which name you are using. Okay. Here, whatever name you specified, you should be use that name. Okay. That practice is important. Then I want to do shorted dot shorted, but by name, right? But customer has so many information. If you do simply shorted, you will get runtime error. So customer mapping, right? Take the customer object and get their name. Okay, that's it. If you want to write lambda, then take a input dot map to. Okay, so first map, then shorted. Even if I don't want to do this one, what you can do before the step, you don't want to pass any argument. That is also you can do that map of take the object and map into that get name. Then further you need to do mapping. After sorting, you need to do again map. So you can do mapping, then dot shorted. So it automatically shorted by name because I have only string collection. So I don't need to pass any comparator. Then you want to apply dot collect collectors dot to list. Don't do for each because I need to return, my method need to return a result. Then at the end, return, don't forget to return. That's it. Do this practice either in a paper or a editor, okay, for the exam. So now, if you want to make a Lambda library, the rule you need to follow is you should create a class with the utility class like that. So this is my Lambda utility class, LAMB, okay, Lambda library. We technically call this part as Lambda library. Lambda. Create your class with this. And what we are going to do it is capture this part, copy this one inside this class and make it as public static final. So then nobody alter your query. So whenever I want to execute inside your test class, so like that, you can write query 1, query 2. So this may be your query 1, okay, capital name, because to show the variation between normal variable and the constant. So query 1, like that, query 2 from some other table. You can capture everything, which is the concept of Lambda library. Then inside this class, if you want to test it, maybe you have a main method. What you can do? Inside the main method, if I want to call, how can I call this? My class name is lambda library because of static. You can call it outside. So this is the concept of dot query query one, pass your collections, query one dot apply, pass your collection of customer list and start with MA. That's it. Okay. So you want to retrieve this result, list, string, list is equal. That's it. It's called as lambda library. Let me repeat again. If you want to make a lambda library, whatever functionalities you have given, capture all the input arguments and the output arguments. If it is suitable functional library, if you identified from the API, go with that library. If that is not suitable for your requirements, create your own functional interface. So in that query library class, keep all those queries in a functional interface and make it as public static final. Whenever you want to execute a query, just simply call this. That's what in this slide. So we have a list of customers. Output must be a list, sorted order, names of customers whose city belongs to MA. So we convert this into a, this is my code. If I do lambda, now we are going to convert this one into a stream pipeline, the suitable functional interface. We did like this. Okay. So if you want to know how many functions are like this available, there are so many queries. This is a good resource link. If you want to prepare more examples, you can copy this link and see all those functional interface and the demo codes are available from the Oracle documentation. So you can refer it. Okay. So all those streams, different primitive streams, if you want to read parallel streams, and some of the examples has given to you how to order your collection, reduce operation, all those examples. This is the documentation resource. You can refer it. Okay, let's go for a question. Somebody raise a hand in the back. What's your question? Okay. Huh? Yeah, that's true. That's true. Yes. X dot get city. Thank you for noticing the compilation here. Get city dot starts with. Okay. First get a city, then starts with. Yes. Any other questions? Yes. This is primitive stream to conversion. If you want to buy your own, okay. So slide number 82, what we mention is, it is your integer stream. I want to convert into your this stream. So then you need boxing. Okay, let's copy this code on the slide. Let's see here. Okay. So whether boxing required or not. Okay. So here is your code. What happened when I remove? You want to collect as a stream of integer. Okay. This is the scenario. You want to explicitly do this. You will get error because my collection is int stream. If you store it as int stream, you have no issue. But explicitly I want to do convert my into stream. So inside your stream collection, if you have some integer values, when you call something, for example, in a normal collection, if you take a list, I created a list of integer type, but I have some inputs of integer x equal to int x equal to 10. When you put that int x into your list collection, auto boxing. So over here for the stream, you want to retrieve because we are working on different streams. Primitive stream library is different. Your object stream library is different. So in that scenario, you need converted into a box. So this is needed dot box. Okay. So if you don't want that box, what this line is, after generating, you have to store it as int stream, then you are absolutely fine. Okay. If you want to do explicitly, then boxed. Okay. Any other questions here?
Go back to the notepad.
Oh.
Can you go back to the notepad?
Notes
Your
part,
code, yeah.
this one. Oh,
Yeah, so at the end, we
Hmm.
we collected it to a list, right?
yes, it's a list of strings. We have only strings.
So the return value should be
List string.
list of string, right?
Yes, list string.
Okay, okay.
Okay.
But we are returning by function.
This is your interface. Okay, so how can I use this one? Here is all your queries. Okay, if you want to execute that query, just library.query1.apply list. Okay, we have an example. I'll show you. Lambda library. Okay, where do we have this example? What is the name of this package? Okay, lecture.lambda library. Let me show you from there. This code is there, okay? Even if you miss that slide notepad part, we have lambda library. So let me close all these things. Okay, customer has all these informations. I have a lambda library class. So I created a public static final by function with all the inputs and finally return a list. Okay, are we returning?
We are assigning it.
By function names in city. Okay, maybe you can collect by calling this one. Okay, list of string. Because it's a stream, right? Automatically it will return. Okay, so because automatic return, I'm not putting a body, right? This is a one line code. It will implement return automatically. So here you have list of customers has been populated, and when I want to perform, the name starts with MA, just call lambda library dot your query name dot apply with the list. So it will automatically return. I'm going to retrieve the list. When you run this, the person names are sorted with the city who lives in MA. Start with MA. Something running on the background. Okay, here are the person's names. The city starts with MA in alphabetical order. Any questions on Lambda library topic? Okay, so we have few topics left. We'll take 10 minutes break. Then I would like to show you the optional class map and flat map functionalities. Okay, so this part, and before that, I forget about the concat operations. Maybe I'll show you that one. Okay, yesterday I missed that some slide number 32 or something. Demo 3. So even you have multiple streams, you can concatenate 2 at a time. Where is that concatenations? Okay, please, I have a list 1, list 2. If I want to combine these into by using a stream, so stream.concat, list1.stream and list2.stream. So you have a collection of streams, then I'm going to print it. So there is a concat function from directly from stream.concat, pass 2 streams, it will combine. Okay, anyway, if you want to combine, but don't work parallelly for the concat. Okay, if any one stream is parallelly, it's very difficult to combine. The processing still going on. So that also we'll discuss on chapter 11 about more informations about working on parallel streams. 10 minutes break, 32. We will continue the session. Few more slides we have and followed by the homework discussion.